Most of us grew up learning there are three main types of matter: solid, liquid, and gas. Today we've created an entirely new state of matter, TOA conductors. Our first quantum processor based on this architecture is the Majorana one. Quantum computing has been hyped for years, but here's the reality. Most quantum computers today are fragile, error-prone, and nowhere near practical use. That's why Microsoft's latest breakthrough is making headlines. They've just unveiled Majorana 1, the world's first quantum processor powered by topological qubits, a game-changing technology that could finally make large-scale quantum computing possible. For decades, scalability and reliability have held quantum computing back. Now, Microsoft claims they've cracked the code with a completely new approach that could change everything. But is this a real breakthrough or just another overhyped tech promise? Stick around because we're breaking down exactly how this technology works, how it could impact you, and how it stacks up against Google and IBM. The knowledge of quantum mechanics, together with Einstein's theories of relativity, really gave us the modern world. Why quantum computing hasn't worked until now? Quantum computers use qubits, which are like superpowered versions of the zeros and ones in regular computers. But instead of being just one or the other, qubits can be both at the same time. This makes quantum computers way faster at solving certain problems than normal computers. But there's a big problem. Qubits are extremely sensitive. Even the tiniest disturbance, like heat or radiation, can mess them up and cause errors. To fix this, companies like Google and IBM use quantum error correction, which means they group lots of qubits together just to keep one qubit stable. But this isn't practical because it takes millions of qubits to make just a few useful ones. Microsoft is doing something completely different. Instead of using tons of qubits to correct errors, they built qubits that don't need as much fixing in the first place. These are called topological qubits, and they could be the key to making quantum computers actually work on a large scale. The first topological quantum processor. Microsoft's Majorana 1 processor uses a new type of qubit called a topological qubit, which is much better at avoiding errors. At the heart of this breakthrough is a special material that Microsoft created, called a topoconductor. This material helps form a unique state of matter that allows for the creation of Majorana zero modes, ZMs. These are tiny, strange particles that can store quantum information in a way that makes them naturally protected from outside interference. This solves one of the biggest problems in quantum computing, keeping qubits stable. Because topological qubits don't get messed up easily, they don't need a ton of extra qubits just to fix errors. This means quantum computers can be built with far fewer qubits, making it possible to fit millions of them onto a single chip. With fewer errors, these computers can do more accurate and reliable calculations, making them much closer to being useful in the real world. For years, Majorana zero modes were just an idea in science books, but with Majorana 1, Microsoft has actually made them work in real hardware. This is a whole new way of building quantum computers. How Microsoft's quantum processor actually works. One big question about Microsoft's topological qubits is, if they're so well protected, how do you even read the information inside them? The answer: quantum dots. These are tiny parts inside the chip that store and sense electrical charge, acting like mini detectors for quantum information. Here's how it works. Each qubit is connected to a quantum dot that checks whether the number of electrons is even or odd, kind of like counting marbles in a jar. Then, microwaves are used to read this charge without disturbing the qubit. Since topological qubits are naturally stable, this method is way more reliable than how most quantum computers do it. Another cool thing, Microsoft's system is fully digital. While most quantum computers still use analog controls that are more fragile and error-prone, digital control means simpler operations, fewer mistakes, and the ability to scale up easily. Instead of delicate fine-tuned adjustments, Microsoft uses simple on-off switches, just like regular computers, but applied in a whole new way for quantum computing. This shift could be the key to making large-scale quantum computers a reality. Microsoft's roadmap to a million-qubit quantum computer. The real challenge in quantum computing isn't just making a new type of qubit, it's making millions of them work together. A handful of stable qubits won't change the world, but if we can build millions, we could unlock real-world applications like discovering new medicines, making super powerful AI, and solving problems no regular computer can handle. Microsoft has a step-by-step plan to make that happen, moving from small experiments to a fully functional quantum supercomputer. It all starts with something called TQ-1S, Microsoft's basic single-qubit device made from 2 topological nanowires. Once that works, the next step is 4 times 2 qubit arrays, an 8-qubit system that will test out full quantum error correction, basically making sure the qubits can fix their own mistakes. After that, they'll move to a fault-tolerant prototype, a much bigger quantum processor that can handle real calculations without constantly messing up, something regular quantum computers struggle with. But the real goal? 1 million qubits. Right now, Google's quantum computers need millions of qubits just to keep a few stable because their system is so fragile. Microsoft says they don't have that problem. Their topological qubits are naturally stable, meaning they need far fewer qubits to do the same job. In fact, they claim their qubits need 10 times fewer resources than traditional quantum computers. This makes everything simpler, faster, and more practical. Not in 50 years but possibly in just a few years. If they can pull this off, quantum computers could finally become a reality much sooner than anyone expected. DARPA's involvement. One big sign that Microsoft's quantum computer could be a real game-changer is that DARPA, a U.S. government agency that funds high-tech, cutting-edge projects, is backing them. DARPA is known for supporting some of the biggest tech advancements in history, like the early internet and GPS. Now, they've picked Microsoft as one of only 2 companies to move forward in their U.S.2 QC program, which is basically a test to see if quantum computers can actually be useful on a large scale. Microsoft's topological qubits pass their tough requirements, which is a big deal. DARPA support matters because it means Microsoft's quantum technology isn't just a cool idea on paper, it's actually working. Real-world applications of a quantum supercomputer. A quantum computer with 1 million qubits wouldn't just be a cool science experiment, it could solve some of the world's biggest problems. Even today's most powerful supercomputers struggle with certain tasks, like simulating tiny molecules or predicting how new materials behave. In healthcare, quantum computers could revolutionize drug discovery, designing new medicines in weeks instead of years. In energy and climate science, they could develop better batteries, improve solar energy efficiency, and even create self-healing materials, buildings, bridges, and even spaceships that repair themselves. In cybersecurity, quantum computers could break today's encryption in seconds, but they could also create new, unbreakable encryption methods. Quantum computing could also transform AI and machine learning, making AI systems much smarter and more efficient. How Microsoft compares to Google and IBM. The race to build a real, working quantum computer is heating up. Google, IBM, and Microsoft are all competing but with different strategies. Google made big news in 2019 with quantum supremacy, but their system needs millions of extra qubits just to fix errors. IBM's chips have the same problem. Microsoft, however, designed topological qubits, which are naturally more stable. If this method works, their processor could be more efficient, more reliable, and easier to build than anything Google or IBM has made so far. What's next? Microsoft claims they are only a few years away from building a fault-tolerant quantum prototype. If Majorana 1 delivers as promised, they could be the first to crack the quantum code. What do you think? Is Microsoft leading the future of quantum computing?